And now, our main purpose here, popularize science, why and how. Julien Bobroff. Thank you.
Thank you. Thank you everybody for coming this afternoon to hear about popularization of science, and thank you to the French Institute and the Minister for this very nice invitation. It's also an opportunity for me to discover Riga. It's sunny, so I'm really happy. So I'll try to tell you a little bit about the way we are doing popularization of science in France, and especially in my team, and the kind of stuff we are developing, and a few lessons we learned about it in France at least. So I have no idea if it applies well to your country, so just take it as it is and take what you like from it. You proposed that the questions would arrive at the end. If you have any questions or anything during the talk, please stop me, interrupt me, and ask or say that you disagree, because otherwise it will be very boring and very long, okay? And especially because it's beginning of afternoon. As a teacher, I refuse to teach on the beginning of afternoons because people are sleepy after lunchtime in France, at least, on the beginning of afternoon. So I don't know how it is here, but just to stay awake, please ask your questions as soon as you have a question, okay? So the topic of the talk is how to popularize the science, and also why. Why should we popularize science? So what I'd like to say is a little bit about our activity in France. Why should we popularize science? How? So what kind of formats can we use in terms of classical formats that all of us know, and more modern formats, and you know many of them, but I will give you perhaps a few examples that you don't know. And also the one specific question which I've been asked to deal about is how to get researchers involved. Why should we get them involved, and how can we get them involved in the game, because it's not so easy, at least in France, to convince my colleagues to come and do popularization of science. So what kind of arguments could we use? Okay. So I start with our activity in France. So we are a small team which is called Physicist Reimagined, and in that team the first things we do is public actions and dissemination. So just doing outreach. For example, we would go into high schools in France and talk to 400 students gathered in a room for 2 hours about quantum physics. Okay, that would be an example. Or organizing an event, a science festival about superconductivity in the center of Paris. That would be another example, etc., etc. And also, we spend a lot of time to create new kinds of tools. We try to explore new ways to do popularization, and I will give you a few examples on how we try to innovate doing that. We also try to work on the teaching of science, new ways to teach science, and I will absolutely not talk about that today, but if you're interested, we can discuss that later. And also, we are developing a lot of research in collaboration with human science about science education and popularization, and I will not talk about that either, but if you have questions, I'd be happy to answer. So just to give you a few numbers, the kind of stuff we are doing, we are a small group, so it's not a national scale stuff, but we try to do a lot of conferences in high schools, for example, general conferences, and also, like the one I'm doing now, conferences about outreach to our colleagues. We are also doing a lot of exhibits. It can be a very small scale exhibit, for example, in the library of the university, of a very big scale in a French big science museum like Cité des Sciences, for those who visited it in Paris. And we also have, of course, online activities in YouTube, a lot on Wikipedia. We try to contribute to many Wikipedia articles, and we found out that it's a very good source of traffic, in fact, and influence, and website that we create, and also, of course, in the French media. We have some collaborations, of course, many in Paris area, many in France, and a little bit worldwide. So not Riga yet, but we'd be very happy to initiate new collaborations with you. So now what about these new tools? How do we create new tools? So basically, we have no idea how to do new tools because we are just physicists, and pretty boring physicists, as you can imagine. So I have no idea. The only way I knew, at least before doing that, is the PowerPoint way. You are there, I'm here, I'm talking for 1 hour, and it's really boring, okay? So in order to imagine new tools, we tried to collaborate with people who have better ideas than us. So namely, it's creative, oh, I'm going too fast, sorry. Namely, it's creative people, designers, artists, videoists, and I will show you how we do that, okay? So these tools ended up in 130 projects since 2013. You can find all of them on our website. So it's the advertising moment of the talk. All of them are free to use. You can use them, you don't even have to tell us, and use them the way you want. And all of them are in French and English, so you can at least use them in English. but most of them are on physics. And most of them are on quantum physics, optics, superconductivity, just because it's my field. And I'm not interested in other fields, I have to say. So all of them are in physics. And we have collaborations, I told. So before going into these examples and these new types of formats and tools, let me discuss just briefly why should we popularize science. So there was this wonderful survey where the journal here asked 270 top scientists what were the main challenges and problems for science in the years coming. So there are many problems, and one of them is that science is poorly communicated. So I was very happy with that, okay? In France, when you're discussing with people from science communication or colleagues or leaders and ask them why should we popularize science, the first answer I always get from my colleagues at least is attract young people to scientific careers. So basically they want to hire new people, okay? I'm not sure we have any effect on that. I have to be honest, when I go in a conference in a high school for 2 hours and I speak to the students, I think I have absolutely no effect on their final orientation. I think the main effect is the quality of the teacher and their family, and I'm much below that. Okay, that's my personal point of view. And also behind that, in France, there is this general idea that people go less and less in science. But if you look at statistics, it's completely wrong. People go more and more in science. We had an increase by about 20% in the number of scientific students in universities in the past 10 years. So it works very well. So we don't even need to attract them. They come on their own, okay? So it's a nice motivation, but if it's the only motivation, just quit the job, I would say. Next motivation is to give a better image of science. People will love science after I come to them. You know that idea? And here again, the idea and the perception is that people don't have such a good opinion of science, okay? But if you look at any survey done in France, people love science. Or at least that's what they tell in the survey, okay? For example, this survey for people in between 15 and 25 years old, okay? 65% of them tell that they love science courses. 33% of them say that they want to do a scientific job. Amazing. If you ask them, what do you think of researchers? Okay, what's your perception of researchers? They love them, okay? Very bad, 1%, pretty bad, 4%, pretty good, 72%, very good, 23%. So they have a very good opinion of researchers and scientists, okay? So we don't need to do anything, just let the general perception, they seem to like science. So here again, if this is your main motivation, at least in France, it's not worthy giving the effort. In France also, I don't know how it is for you, but there is this general feeling that people don't perceive science as part of their culture and education. They think that history, philosophy, literature are really culture, but science is something else. So once again, when you go to the numbers, this is not true. When you ask people, tell us if it's a cultural activity, the first one is visit a museum, okay, which sounds reasonable. The second one is science. That's amazing. It goes above trips, above cooking, above theater, above listening classical music, above reading novels, above music, above movie theaters. We are really top 2. So I don't think it means that all these people at the end of the day go to a science museum, but at least they'd like to answer that they'd wish to. I would say it that way. So it's hopeful. Now let me give you the bad number, because I just gave you very nice statistics. So let me give you the bad one, the one which we really have to worry about in France. This is the one. What did you prefer at school? Okay, you have to tell me the 3 things you preferred at school among all the curriculum. Okay, so in France, 42% of the people among the 3 preferred ones tell French literature. Okay, then history, then mathematics, geography, physics, and chemistry are here. Only 10% tell that among their 3 preferred disciplines in schools there was physics or chemistry. We only have Latin and geometry, which are below, more or less. Okay. Very poor. So basically what it means is that in France, at least, the students and the general public have an awful memory of their physics lessons. Okay, at least for my field in physics. And I think it's the same for chemistry and biology. And I think that's the main thing we have to fight against. As I told this morning in another talk they made me do, you know when you're at this dinner moment and each one has to tell his profession and his job, And, you know, and the pressure comes like that, and then arrives your turn, and I have to say, I'm a physicist. And then everyone like, oh God, he's a physicist. Like you said, more or less. And, oh no, I'm afraid he's going to tell me about physics, and that's my physics teacher, and oh, the physics classes. And then usually, my experience at least, for having done that the past 25 years, is that everyone will tell me about his physics teacher, and how bad he was, and how, etc., etc. And we'll not hear about physics anymore for the rest of the dinner, okay? And I think that means something. So people love to tell that they like science because it's nice to like science. But at the end of the day, I'm not sure they have good memories in France of science in school. And you have to fight against that. And that's a good motivation for me, at least. Another motivation is to fight against stereotypes. What do you think a researcher here? Try to draw, you could have asked, try to draw a researcher, okay? So the best thing, usually for stereotypes, I love to go to Google and to type and to look at Google image. So that's really the honest, if you type physicist and you click, that's what you're going to get. And I have to be honest, these are physicists, so it's not wrong. So basically a physicist is old, white, and with a lot of mustache and beard, more or less. And that's it. And black and white most often, okay? And we have to fight against that. And it's And then the other version of it, if you go a little bit lower in the Google images, are then like Big Bang Theory people, you know, these big glasses, and the guy completely nerd or geek, like that, etc., etc. And usually no woman at all, at least in physics. I didn't pick biology or chemistry, I picked on my own field. So we have to fight against these stereotypes to show that researchers can be young, there can be women, they can be dressed like normal people, etc., etc. Okay. Here again in France, at least, we have a lot of problems with some societal debates. I mean, real big issues. I mentioned just a few of them: climate change, Darwin evolutionism, genetically modified organism, and nuclear plants versus renewable energies. And there are a lot of debates and legitimate debates in society. But in these debates, sometimes people tell crazy stuff, or people don't know how to handle science properly. So I think there is really a motivation here, not telling people what is true or wrong, but giving them the tools to be able to decide for their own what they think. And that's a motivation. Another motivation, for me at least, is to fight against fake science. When I'm giving these quantum conferences, half of the questions are about weird medicines, you know, this quantum therapy stuff. And then I went to the websites of quantum therapy, so they are speaking about resonances, energies, and holistic something, which will basically cure everything using quantum something, okay? And then usually they sell you something very expensive to solve all your problems. Or another way, when I'm doing conferences on magnetism, it's one of my fields, I always have these questions about how magnets would cure everything. So I went to Amazon to check, and indeed, you can find an amazing full-body magnetic therapy set where you basically cover all your body with magnets, okay? And it's very expensive, but very efficient, and it cures you everything. And there are many Hollywood stars who apparently use the bracelet, at least, because it's very efficient. So my point is not to tell people what they should believe or not believe, and I don't want to enter into the belief issues. I just want to tell them where they should not use science as an argument, where science is misled or misused. And if it's a belief, I have no problem with that. But if they say, because science proved it, or because it's scientific, then I have a problem. And these are my main motivations. Would you have other motivations that I didn't put? What would be your motivations? Are you motivated? Yeah? Do you see any ones that I didn't put? I mean, when you start your job in the morning, if you want to do science communication, what would be other motivations? You have no others? I put all of them? Wow, you're a silent audience. Okay, so let's stick with that. So, to summarize, the idea is to popularize is, of course, to explain science. I mean, that's the bottom thing. But not just to the people who would go to scientific studies. It's too easy. I think it's very important to educate all the people and to give a good understanding of modern science to every citizen and to enable them to understand what science is and what societal issues are correlated to. So to explain the scientific method is also, I think, part of the job, and to fight against stereotypes. And also trying to give a good picture of what research is and what a researcher is and how they work in their daily life. So these would be my motivations. So not going directly to the how to do it, when I tell that to all my colleagues, scientists, they all agree. Wonderful. Yes, you're right. We should fight against stereotypes. We should put more science into societal debates, etc., etc. But the two usual answers just immediately after that, just to tell me that they will not help me, are the two following arguments. So I don't know if you have the same. So the first one is, I don't need to do it because I'm very bad at it, and there are so many people so good at it that I don't need to participate. And for example, you have these science museums, or you have these journalists, or these media people, or these YouTubers who do it wonderfully, and it's their job. So why should I bother doing it because I won't do it as good as they do? So that would be the first counter-argument, which is very valid. Okay? So I try to tell you why I think it's wrong, but at least it's what they tell me. And the second one is that I don't have time, and it doesn't help my career, which is even better arguments. Don't have time, it's true, they don't have time. And it doesn't help my career. Well, in France, it doesn't help your career at all. You should better hide it if you're doing popularization of science than advocate it when you want a promotion, for example. I got promoted professor without telling anything about my popularization activities. So what can we answer to these people? First, when they say there are other people who are better at it, I have to be honest, I think they're right. I think they're not that good at it, except a few people, and that professional people are much better at it. But there are a few stuff that other people will not be able to do. And the first one, of course, is to talk about very recent hot topics. No one will be able to talk about my last discovery in quantum physics but me, okay? Because they don't understand. Okay, so if you want the people to talk about your specific field, you have to go there and do it yourself. Fight against stereotypes. It's much more efficient if I'm there and I'm standing there and saying I don't look like Einstein to fight against a stereotype than telling scientists don't look like Einstein. And for example, we have all these high school conferences where we send a lot of women scientists, and it's very strong. I mean, it's much more efficient than anything else to fight against the male gender issue disregarding scientists. And also, the scientist will be the only one who will be able to tell what a lab looks like, what a daily life in a lab looks like. And this is very important from my personal experience when I go to these conferences. Most of the questions are about that. They are never about the science I told for 2 hours. Most of the questions are, okay, but what happens when you do a discovery? Do you get more paid? What's happening at the cafeteria? What your lab looks like? Is it big? Is it small? Do you work with 1 people, with 10 people, with 100 people? How long does it take to make a discovery? All these very practical daily life questions, and only the researcher can answer them. So I think the power of testifying about your own job and life is very strong and cannot be replaced by anyone else. And of course, if you're enthusiastic about your research, that's really something which cannot be replaced by a professional. So I don't mean here that professionals should not be there. I mean it's a collaboration and there's a room for everyone. But if the researchers are not in the game, they will lose that. That's my personal opinion. So who would disagree or give a comment or another opinion or a compliment? You're still completely passive? You have to show me that you're still alive. Yeah? Okay. And then when we want to sell it to our colleagues, we try to find things that they might get from it, which might be useful. So the career we cannot, okay? So we tried to find other arguments. So this is my top list arguments to trying to sell popularization of science to other colleagues. The first one is, if you learn how to popularize science, you will be better in your own conferences, in your scientific conferences. I don't know, who attended to a real scientific conferences here? The ones where you have a talk each 10 minutes or so with a PowerPoint with just too many stuff and you don't understand a thing for 10 minutes and then for 10 minutes and then for 10 minutes and then you're so tired and you want to go to the coffee machine, or you just do your email during the full conference and everyone does his email for the full conference except when it's his boss or his colleague, In these conferences, my personal experience is that as soon as you have someone who suddenly talks well, suddenly engages with a big question at the beginning and doesn't jump directly to his results, etc., suddenly everyone is staring because they waited for that talk for the full day or 2 or 3 days even, okay? So if you're good in popularization of science, my experience, and it's a 100% check each time, a colleague who was good in popularization was amazing in a pure scientific conference. And you could argue, why does it matter? At the end of the day, it's really your article and publication. I mean, for those who know science and who know how it works, being good in conferences is very important to sell your stuff and to show that your science is important. It should not be, but it is. Okay, so that's one argument. The other one is that more and more the scientific journals ask you to do a broad introduction to your article. It was not the case 10 or 20 years ago. At the beginning of my career, 25 years ago, they never asked for a very broad introduction telling how important your stuff is. Now they do. And it's very hard to write it. But if you tried to sell your stuff to a high school 3 days before, it's very easy to write it usually. And also, when you're doing highlights associated to discoveries, it's easier to write it. That's something which really talks to the researchers. Money, okay? If you want to get more money, popularization is useless, but you will be much better at writing your grant proposal. You know, when you have to tell why you want the money, usually the process is that there is one specialist referee of your domain, but there is one less specialist. And if he doesn't understand anything, he's not happy. So writing better calls and grants proposals, I think, is important. Also, from my experience here again, you hire people easily if you are good at selling your stuff. So basically, when you have all these students who want to do a PhD, but not enough students for all the researchers, and you have to fight with the colleagues to get a PhD student, okay? If you sell it well, if you engage with them, if you show them the big question, if you bring them to the lab, if you're enthusiastic, etc., at the end of the day, you get the students, okay? So usually you recruit easier if you're good at selling your stuff. And last but not least, it's fun. They don't know it, but when they participate to a popularization action, often they find it fun and engaging, and it feels good because suddenly you're not just with the colleagues anymore, not in your lab for the past 20 years, and suddenly you see other people and you discuss with them with your amazing science, etc., etc., and it's refreshing. Okay, so just that's a pleasure. And also the idea of reflexivity. Suddenly you have people in front of you who ask you very stupid and naive questions like, but what's the big question? But what's the use? But why did you spend the last 10 years? So it can be very painful, of course. But also, I mean, from my personal experience, for example, when I started Popularization, I think it was 10 years after I started my career. And suddenly when they asked me, okay, what's the big question? I had no idea what was the big question anymore, you know. I had been 10 years studying impurity effects in high temperature superconductors EBAQO. It was a very specific topic. And suddenly I had to think again, yeah, by the way, what is the big question? So it's very good and refreshing to think again about your work. And usually the public gives you this feedback. Do you have any other good argument that I would have forgotten? Yeah.
Yeah, actually about the funding, that there is direct consequences as well. They actually evaluate the social impact. And if you write that, oh, I will tell people that why this is necessary, it's good because then people know why should they give money.
You're completely right, and even more, in many grant proposals, there is a dissemination section, explicit one, where you have to put something. And if you're telling, okay, we're going to do this bunch of conferences or these science fairs, or we're going to collaborate with science communication people to do this and that, it can help to have the proposal go through. I mean, we had this experience, at least in France. Other ideas? Yeah?
Very naive, but you're going to make society better.
Yeah, of course. Wow, okay. That's a long-term strategy, but okay. I'm trying to think about my wife, but she was PhD also, so it was easier, you know. We didn't have to convince each other. Yeah, good point, okay. To date, okay. Other ideas? Okay. So we did the why, now let's do the how. So how should we popularize science, or how can we popularize science? So I will do the how in general, and then how for researchers, okay? So first, the how in general. So just talking a little bit about formats. So you have the classical formats, the ones everyone knows, conference, demonstration, live demo, books, magazines, exhibits, science fairs or festivals, TV shows, and all of them work very nicely, and I have nothing against them, and I'm doing many of them also. So I'm not trying to say that the new is best than the old, okay? I think these are very valuable and worthy formats to still explore and to maintain. Now, what about new formats? There are many new formats. I will not do all of them because that would be an endless catalog. So I chose a few of them which sounded nice for me. The first thing, of course, is to revisit and change the conference. Okay, this very boring thing we are doing now, really, it's awful. No one at the first row, as you see. All of you are like that, taking a few notes. Me speaking, you have almost no opportunity to talk back. And it's really a top-down conference, even if you're higher than I am. So people try to revisit that. And the general strategy was to leave shorter time. You have only 10 minutes, okay? Not allowing the PowerPoint. You have only one slide, okay? And not allowing too technical stuff. You have to start with a personal anecdote, you know. So when describing that, I'm describing exactly what TED Talks are about. And this was really the emergence of these new type of talks. So there are many other kinds of series of talks, but this one I think is the most popular in the world. And basically the idea is that they give you only 5, 10 or 15 minutes. They don't allow you to have a full PowerPoint, and they just ask you to make it more personal and engaging. And I don't mean it's better than the previous formats. I mean it's different, okay, at least. This is, for example, Aaron O'Connell, who explains his PhD about a quantum visible object for 10 or 15 minutes. And it got 1 million views, which is not too bad for quantum physics. You can do even worse or better, I don't know. This is a contest we have in France and among all the French countries in the world, which is called the 3 minutes PhD contest. So basically they ask PhD students to explain their PhD in 3 minutes. And you have the clock ticking. And if you're below 0, you lost, okay? And then there's a jury, and there are local competition, national competition, international competitions. And the legitimate claim here is, can you learn anything in 3 minutes? I mean, can you explain anything about 3 years or 4 years of work in 3 minutes? And I think it's not what matters the most. When you're discussing with people in the audience in these kinds of tournaments and asking them what did they remember, etc., basically they don't remember anything about the science at all. And it doesn't matter. What they remember the most is that a PhD student seems to be a nice person, can be a man or a woman, can work on many different topics, doesn't look like the old physicist I showed you before, and is enthusiastic about his or her work. And I think that's the main message, and it's already a nice message. So each time people tell you, but what will they understand if I don't have time enough to explain, you can decide that your aim, your strategy, is not to explain the science at bottom, because you would need 1 hour, but perhaps to give other messages. Science can be fun. Science can be very diverse. You can have human science, you can have physics, you can have biology, you can have economics, and all of them are very good PhD topics. One example of actions we did in my university, which was the science break. So we wanted the researchers to give outreach talks to the students of the university. And the challenge was to do it at lunchtime. And believe me, if you don't teach at university, at lunchtime, the students don't want to see their teachers anymore. Don't want to go to science anymore. They want to play cards in France, basically, okay? Tarot or bridge or belote, okay? Very famous. So the challenge was, how can we attract them? So this is what we did. We created something which lasts 30 minutes only. It's in French, but I will translate. New type of conferences, you got that? So the idea is to divide it into 3 parts. The first part is 10 minutes, and it's one researcher telling his very last discovery. So that guy told us that he discovered something about waves, basically. Your last article in 10 minutes, okay? The second one has to tell about his daily life in a lab. So it was Wiebke who told us what a typical day would look like in her lab. I arrive, I take a coffee, then I go to the experiment, then I do this experiment, etc., etc. And the last part, 10 minutes, is a live experiment. So it's me doing stupid stuff about superconductivity, basically. Okay? And the success of it, because we attracted hundreds of students at that, to be honest, is what happens just after. We tell them, you won't have time for questions. We won't allow any time for questions because it has to be only 30 minutes because you don't have much time for lunch. But after the 30 minutes, there is a snack offered to everyone for free. Okay, food attracts students, basically. Free food. So that was the trick. And of course, at the snack, the researchers were there and could engage with the students and discuss with them. And they could ask all their questions. And it was also a nice way for us to train researchers who are not used to it to do something different. just 10 minutes, short formats, and to change it very often. And it was a way also for the students to see their teachers in a different position. Suddenly there would be researchers with their own discoveries. So that's an example of short formats. There are many other examples in France. Almost each university in France develops its own format in 10 minutes, in 13 minutes. In some of them you have a chair and you're sitting and you're telling like a story near the fire, etc., etc. So you have many ways of doing that. Any questions, comment, reaction? No? Next new formats, of course, are internet and video, science videos on internet, so YouTube for sure. Many channels, of course, the worldwide most famous are from America, and these three are among the most famous, so typically each video is 10 million views, okay, so it's not a small number. And in France, we have YouTubers as well, which are, of course, less popular, but this guy has 1 million subscribers, typically. So it's sizable numbers. And these ones are the most famous ones among science popularizers now among young people. When you ask young people, who do you know in science or in science communication, these are almost the only names who come, and never the name of a researcher or even a TV star. It's done. I mean, there is no TV anymore, now it's YouTube. Okay. So one big question is, should researchers do it? Should they have their own YouTube channel? And there were a lot of questions and debate in France about that. The CNRS, the French National Research Agency, decided to create its own YouTube channel. So it's not the researcher itself, it's a science explainer who is a former PhD student, but she's a science explainer. And in each video, she's telling about a very recent discovery of one of the researchers of the CNRS and explaining it in 3 minutes, typically. And she's using all the typical codes of YouTube videos. So I think it's interesting because it's a French National Research Agency who decided they would agree to do these weird formats, YouTube formats, to reach out a new audience. And they're beginning to having a sizable audience. But a lot of researchers don't agree, think we should not go to these YouTube formats. Some others think we do, and I think the debate is open. I don't know. Who has an institution who would have a YouTube channel? Yeah? And do they have specific YouTube videos, or it's just like typical science communication videos, which are or documentaries? Okay. There is no specific YouTuber who would do like a weekly something. Okay. Other people? So I think it's an open question. Should we do a YouTube channel for a university or something like that? But there are many debates. Same debates for Instagram accounts or Twitter, etc., etc. Another type of new formats which developed recently in France and are now more and more popular are comics. Okay? For example, this book about quantum physics, or this one about PhDs, so each PhD in 3 pages. This one is from our own, so we asked Eloise, who was an illustrator, to come to the lab and spend 4 months in the lab. And during the 4 months, we made her experience awful stuff. Like she would have to spend 1 week with a researcher working on very low temperatures. She would have to spend 1 week with a PhD student just before his defense. She would have to spend 1 week with the students in the courses, etc., etc. And each time she would have to draw a cartoon, and we would put it each week online. So we got a big success with that. So this is the lab room. All the stuff you can find in a lab room. This is a typical day in the lab where she explains what she saw. This is Pierre, who welcomed her for 1 week with him, and she analyzed what he told her about the PhD and the different steps of a PhD, etc., etc. And it ended up with an online version, and also, surprisingly enough, in a science museum, in the Palais de la Découverte, which is a big French science museum, where it was converted into huge panels to do an exhibit in the main corridor. So often we have formats which end up in completely different formats, and we're happy with that. Yeah. Okay, that's a very good question, and most generally speaking, the question of the audience. So I'm going to be honest here. I have no idea and I don't care. So that's the first answer, which is not a good answer, okay? The usual answer I give when I want money, for example, is I'm targeting teenagers from 15 to 18 years old, or I'm targeting, etc., etc., and I give a very specific audience. My personal experience is that at the end, I have no clue what the audience is, and when I try to look at the statistics, it's always surprising, and it's never what I intended at the beginning. And to make it even worse, I discussed that this morning, so just in a few words, we did a recent survey where we showed on YouTube we asked people on the internet to watch 3 videos, very short videos, okay, 30-second video on the same topic but with different styles, okay? One very modern, contemporary, one very classical, and one with animations. And we asked them what they thought about the videos, okay? Tell us between 1 and 5 what would you think of the clarity, of the style, if you liked it, etc., etc. Okay? 1,000 people, and 1,000 people from very different backgrounds, professions, level in science, man, woman, young, old. And then I sorted out the answers and trying to see, what I was interested to see is perhaps the artists will like this video better and the scientists will like this video better and the young people will prefer that one, but the old people will prefer that one. If you look at the data, it's amazing. They all are absolutely identical. Whatever the age, whatever the gender, whatever the profession, whatever the level of science, the 1,000 people gave exactly the same marks. So I'm very doubtful now about thinking about a specific audience before because I don't have any clue anymore about the audience. So I think it's a good question, but I don't have a good answer. Well, I could give you an answer, a fake answer. This is for teenagers, but I don't know. So what I do usually when I have these big people is I give them an audience, targeted audience. I look like I'm very serious and I made a lot of studies, but then I don't care about, I care that many people watch it, but I don't know and I don't care about who watches it. But perhaps it's not good to do that, I don't know. So do-it-yourself is a big movement, especially in Science Museum. It started in San Francisco at the Exploratorium. And the idea is don't do a science museum as the usual one where you just push buttons or watch demos, do it yourself. But really do it yourself. Create your own stuff, create your own experiments, participate, engage. And this is also going with all the Fab Labs and makers philosophy and clubs. And it's very interesting and developing all around the world. And we are doing that also in teaching. This is our own students in kind of Fab Lab teachings where we ask them to do physics in a Fab Lab spirit. So to create their own stuff with low costs, Legos and plastic and subway tickets and ending up still with physics experiments. And the other prolongation of that, even further away, is the citizen science. So the idea here is to ask the citizens to help you do science, real science, okay? So there were many games, for example, online games or movements doing that. It started in biology with Foldit or in astronomy. Let me show you that one. That one is a good example. It was made in Denmark, in Aarhus. And basically they ask you to play a video game where you have to move this stuff without making it overlap. And this is a quantum wave function. Okay, so you have to play different steps to understand what you're doing. At the end of the game, you should have understood a little bit of quantum mechanics. And the researchers, comparing the games of everyone, will be able to find the best strategies and to use it in their own labs. So when they explained to me that, I laughed, of course, I didn't believe in it. They had 3 million people playing that game, okay? And they claimed that they got an algorithm from one of the players which was better than the one their own theorists found out with their simulations. So I laughed again, and then they published in Nature an article showing the algorithm. Oh. So then I was amazed. I didn't believe in it yet, but still, it's amazing. And they have a huge team about that, and there's a big movement all over the world creating new types of science games, having the public participate in science. Of course, the question behind that is, how far can you go? How far can you make people believe that they are scientists as you are? How far can you have them participate to the science or participate to the debate or even participate to the founding decisions, you know? So there's a tight limit here, and I don't have any clue about that, but I think it asks many questions. Any comments, reaction, testimony of something you saw similar or you did similar? No? I keep on? Okay. So, as I told you at the beginning, what we are trying to do in my group at least is trying to work with other people who are more creative than we are, basically. So, we are starting from our world, which is just pure physics, and we are working with designers or artists or videoists or illustrators to create new types of media. So, how do we do it differently? Let's say we have 3 ways to do it differently. One is to explore a topic no one explored before. And it's very easy in my field because no one did anything and because the topics are so awful. So for example, crystallography, vortex spinning, dilution cryostat, topology. I'm absolutely sure when I'm doing an outreach project on topology that I'm the first one to do it, almost. Because no one wants to do it, it's too awful. The other way is to explore new formats. So we really try to work on the format. Let me give you an example. This one, for example, is a format to show a real science article, but in a nice way. So we are coming with these huge pieces of paper. This is 1 meter, okay, and we put them on the table, and we ask people to come, okay, and we suddenly pop up small illustrations which will explain what's in the article. This figure that you cannot understand, in fact, that's what's happening, etc. And we progressively, as a science explainer, explain what's happening in the article in a new way. And of course, when we leave the room, we leave it like that, and that guy does the work instead of us. So it becomes a small exhibit. And it's a new format, and then we tried to give it to other researchers who explored it and did it for their own articles, and it seems to work because someone did it in biology, for example. I did it in physics. And so you bring your big article like that, you put it, and then you can tell about your own science in a nice way. Another thing we love to do is to explore different scientific levels, to start from something where there is absolutely no explanation to something very deep. So let me give you the example of superconductivity. This is something which has no explanation at all. It's just a superconducting Eiffel Tower. So it levitates with quantum levitation. And you don't understand anything about the physics, but it's fun. Okay? So here, in fact, it takes a long time to cool down and to work. It takes 20 minutes. So people wait for 20 minutes. And there you can do a lot of science explanations because they are just stuck, and they wait. So you have a captive audience. Then we can make a little bit more. So this would be, for example, just in 4 squares trying to explain what happened in the movie before. And we made that with illustrators. And then if we want to go one step further, we made this big website where we have all the superconductivity explained in a very comprehensive way, and which is now the most visited website on superconductivity because it's the only one, basically. There is no merit at all. But we also love to explore different ages from the ancient times to more recent. For example, about low temperatures. This was from the coldest book in the world, so it's a book that we put in liquid nitrogen and which suffers a lot of stuff. This is more recent. It's big posters about a discovery made in the 80s. And this is very recent. In this one, we asked an illustrator to interview researchers from the lab. So she went to a researcher and told him, where do you do your discoveries? Or what was your worst nightmare? Or what was the biggest accident in your lab or your most disappointment? And they give their testimony, and then she made drawings from it. So for example, that guy told her here in French that basically he does all his discoveries at the cafeteria talking with the colleagues. Okay, at the coffee time, when he talks with the other ones and has to argue, suddenly new ideas come to his mind. And this ended up in postcards. So we just give postcards at science fairs, which are very nice looking, just explaining a few hints of the life of a physicist. And the last way we love to explore is the weirdness, unconventional or originality, I don't know how you call it. So for example, if I take laser, the traditional way would be to have just a 3D animation. So we did very nice, classical 3D animations to explain the laser and how it works. I will not go into the details, it's a very small moment of the animation. You can do it more unconventional. This was an app for iPad, okay, or for tablet. And the idea was to take science fiction movies and to show how they would become with real lasers. So for example, in Star Wars, basically you break all the space shuttle with your lasers because it doesn't stop the laser beam. So it bumps to the, so laser, like in Star Wars, would destroy everything. And there are many other movies, of course, in the application. And then you can go to very, very weird. So be prepared. That would be my example of very weird. So let me explain before. The guy who did that is a designer, and it was a project about quantum physics. And he told me, I'm going to try to give you pedagogical tools to explain all the basic quantum phenomena. Okay, quantization, duality, entanglement, etc., etc. And that guy was interested in dancing and choreography. Okay, so in this one, he tries to explain how a laser works. So let me explain to you just in a few words how a laser works so that you can see the link with the movie. Basically, in an atom, you have levels. It's very discontinuous, okay? Levels of energies. And in quantum physics, you cannot be in between levels. You have to be in that level or that level, and you will suddenly jump from a level to another level if anything happens. So if you take an atom, and you excite it, okay, move it or put electricity into it or whatever you want, usually you will jump from the lower level to a higher level, like an elevator, okay? So now you're in the excited state, higher level. You're there with me? And now, while it's in the excited state, very fast because it will want to go back, okay? So go fast and send him a little bit of light. 1 grain of light, 1 photon. You send it. What happens? Einstein thought about that. It's very weird. You would think he would go higher. In fact, sometimes it can decide to go back to its initial position, so to go lower. So the fact of sending that new grain of light, that new photon, will make the atom slow down and send his own piece of light, because when he goes back, he sends his light. So you started with 1 piece of light, 1 photon, and you end up with 2 photons. So you have amplified lights. And if you put a mirror here and start again, you will end up with a laser. So now, that's the interpretation. That's the atom in the middle. That's the photon on the right side. The excitation of the atom. So I encourage you to see the whole movie, which is even worse than this part. Okay? Exactly. So usually people ask me, so smart people tell that, but the other people tell me, what's the use? I mean, okay, you got fun, but what's the use? I use that movie at the beginning of every course I do about quantum physics or lasers. And I show that to students, they have fun, and then I tell them, tell me where the error is. And the error is in the fact that you saw that there was a blue and a yellow at the end. And the two should be identical, otherwise it will not be a laser. Okay? And in fact, I told the artist at that time, I told him, you're wrong. You have to change it. And he told me, no way, because it took me 1 month for each costume. Because he does it wire by wire. So he told me I cannot change the colors anymore. So we thought about doing After Effects, changing of colors, and we decided, let's leave the error and let's have people react. So suddenly you can engage with the popularization, so it's very good. And I didn't warn you in advance. Huh? So let me give you a few examples of the type of stuff we are doing in our group. You saw some of them. So pedagogical animations, as the one you saw, we developed many of these animations. Classical one, where I would explain, for example, here, tunneling effects. But even though it's classical, we took a lot of care about the graphism, about all the way we would draw stuff and the way we would put the sound and everything at play here, so that we could do a huge family of animations like that. And we made like 20 or 30 animations like that. For example, animations about all the possible new types of microscopes, okay? And I think the interesting part is what we did with them after that. So you often have very nice projects like that. We end up on a YouTube video channel with 20 views and that's it. And it's very sad. So we really try to promote that among teachers. And we prepared them in a specific format. For example, you can download them with or without the legend. And we found out that the one which is the most downloaded is the one without the legend, because the teacher wants to look smart, you see? So he will look the one with the legend, but then he wants the one without the legend and showing how smart he is, or she is. We put them without any logo, okay? There is small credits at the end, but you can use them. We put them on Wikipedia in licensed Creative Commons, so completely free to use. You don't have to ask me, you can put it wherever you want. So it was so easy for people just to hack them that it ended up in very unexpected places, like in scholar books, you know, for students, or in scientific conferences, or in media stuff, or in documentaries, or wherever in the world. And many times now I find these animations everywhere, not because they are nicer than the other ones, but first because they exist, and because they are so easy to download and use for your purpose without having to put the credits or tell everyone, etc., etc. What time do I have left? I just want to have a rough idea. It doesn't mean anything to me. You have to tell me how many minutes I have. Half an hour, wonderful. Another example, we wanted to explore how to change that boring live conference. So we ended up with that, small cards. So the idea is that I do that in live conference. So I have you there, and I'm going to put decks of cards like that, and ask you to choose which one you want. Okay, so you will pick one, you will vote, and I will take the one and tell you the story. Okay? So let me give you an example. So I don't have the cards here, sorry. So you will have to pretend that it's real cards, and I'm doing it, and we are just like sitting together, and it's a nice warm evening, winter time. The idea was to construct the story each time the same way for each discovery. Where, who, what is the question, what is the discovery, what are the applications, what's the article, okay? 8 cards each time. So I'm going to give you an example with superconductivity because I don't have time to make you vote, etc., etc. Okay, so no choice. So we're in 1911, and we're in Leiden. Leiden is a small university town in Netherlands, okay, very nice town. And in Leiden University, you have a lab. The lab is owned by Kamerlingh Ons. Kamerlingh Ons is the typical frightening scientist, you know, old guy, specialist of low temperature physics and thermodynamics. What Kamerlingh Ons loves to do is to cool down stuff, okay? And to do that, he has created an amazing lab. The lab looks like that. If you go to Leiden in the museum, you will see the lab. It's still there, okay? And basically, it's big bottles, which are like thermos, you know, which are very insulating so that if it's warm outside, it can be cool inside. And inside that, you have some helium. Helium is a very rare gas, and he's going to be able, with huge pumps, to liquefy helium, to make it liquid. And when he makes helium liquid, he's able to go at about 1 degree from absolute zero, minus 270 degrees or so, okay? And that's in 1908. So in 1908, he has in his lab the place coldest on Earth, okay? It's 20 times colder than the previous records. So he knows at that very moment that anything he will put there, he will be the first one to measure it at these low temperatures. And in 1911, he decides to ask this question. If I take a piece of metal, this is mercury, but it could be any metal, does it work better or worse if I cool it down? That's a good question, okay? Simple question. So he's going to try to do that. Well, in 1911, he's in the lab. He's sitting, writing down small notes. There are 2 people handling the experiment. And there's another guy, Gilles Holst, the physicist, who's in another room. And the reason why is that in the lab, the pumps are so big that everything vibrates. The walls are doing that. And the guy has to look at the electricity in the piece of metal using what we call a galvanometer. And the galvanometer works that way. Each time he sees the current conducts well, he sends a spot of light, and you just have to follow the spot of light on the wall to see what is the resistance of the metal. But when the pumps are there, it does like that. It vibrates. So he's in another room to make the experiment carefully, and he's shouting through a tube to the other guys the measurements, because there is no phone at the time, okay? So you can imagine the scene, a huge noise, Kamerlingh Ons noting down, they cool progressively the metal, and the other guy tells, 1, 2, 1.5, etc. Okay, and he's drawing live the measurements, and that's the measurement done by Kamerlingh Ons' own hand. This is the temperature. You cool down, and this is the resistance of the metal. So here, basically, what it means is that your metal conducts, but not that well. You have a little bit of resistance. Okay, so the electrons travel in the metal, but suffer a little bit of bumps, let's say. And suddenly the guy from the other room shouts, 0, 0, 0, 0. And everyone is amazed in the room because it's impossible. Because suddenly they measure no resistance at all anymore. And it's impossible for a physicist because for a physicist, no resistance means that the current flows perfectly. It means that if you take a ring of that metal and you put current in it with a battery and you remove the battery, the current will stay forever. And so Kamerlingh Ons says, let's try it. So they take a ring, they put current in it, and they come 6 weeks after, and the current is still there. So he has discovered superconductivity. So the result is that suddenly, in metals, below a certain temperature, a new state of matter appears, which is amazing. This is the article. I love to show the articles. So the article is basically how you should do it if you want to do it yourself. In science, you have to give the recipe. You cannot hide it. So the article is full of the schematics of the experiment, telling you what you should do if you want to see if it works or not. And nowadays, this is used a lot, for example, to make the fastest train in the world in Japan levitate, and that train goes at 600 kilometers per hour, or the MRI in hospitals work, or new types of electric conductors. And for that, he got the Nobel Prize in 1913. So you see, it's a new way to show discoveries, and we did that for many discoveries. And what I like about this format is that it can be used for any discovery, even very recent ones. So now we have other researchers who hire the same illustrator to do their own decks of cards. to explain their own discoveries, even if it doesn't end with the Nobel Prize. Also, as I told you, I always love to find derivatives. So from these cards, we also made exhibits, so just posters, because posters are the easiest thing you can print if you're, for example, a high school teacher and you want to put something in your classroom. And yet they can download it as a PDF file and just print it. Another example, we love to do animation movies. So this one, for example, is trying to explain what soft matter or condensed matter is about. So it's another kind of language, you see, I have to go fast, but basically showing what nanophysics is and condensed matter physics is. Posters, as I told you, we love to do posters. This one is one of the most recent ones. I don't know if you know that, but in exactly 3 weeks, we will change the way we define units in physics. We will change the kilogram. Up to now, the kilogram is a piece of metal hidden in Sèvres, nearby Paris, in the underground of the lab, and you're not allowed to touch it. Each 50 years, they take it out and weigh it to see if it's still a kilogram. And that's the way the kilogram all over the world is defined. Okay? You compare to that piece of metal, and if you have the same weight, yours is a kilogram as well. But then they discovered that every weight changes in time. So it was a nightmare because you don't know how to distinguish and how to decide what a kilogram is anymore. So they had to invent new ways to define the kilogram, not to be dependent on something anymore, to have a general method that you can put in a lab, wherever you are, if you're in space, if you're on Earth, if you're talking with extraterrestrials, to tell them how to do it independent of any piece of metal. And they succeeded to do it, and it will start in 1 month from now. So it's an awful topic for science popularization, because people think, so what do we need for that? Will the kilogram change? I don't care at all. So we thought, what can we do with that awful topic? But it's these typical topics that no one wants to do. So if you do it, usually you're in a virgin territory somehow. So we did instruction manuals, like IKEA manual you have to mount. So how can you build your kilogram? So basically, this is the recipe you have to follow to build your kilogram. So that's what you will need at the beginning. You will need some theories. You will need some stuff. And then you will have to throw away the ancient methods. So it's a way for us to tell about history of science. And this is the new method. I don't have time to explain you the new method, but it's amazing. And then you have to share. Once you have your kilogram, that will allow everyone to create his own balance. And that's exactly what's going to happen mid-November. And we did that for all the units. And then we put it on internet. And now in France, for example, so it's in English, but it's also in French, many teachers just take it, print it, and put it in their classrooms to have a topic to discuss. We also love to do real experiments, as you saw. This is an example. Here again about superconductivity made with a designer. So it's a small circus that you can bring everywhere, which is very light, very easy to implement. And you have fun with birds. So it's another way to demonstrate superconductivity, but in a friendly environment, let's say. And you have to fill it with liquid nitrogen. And you perhaps don't know, but it's not only levitation, it's even better. Look at what they do now. It can be suspension as well. So you can hold without touching. And if you warm it up, it stops. So you see, it's a typical stuff we would not have been able to do without the designers, and he would not have been able to do it without us. So the collaboration really makes something new. And so the last part of my talk, sorry, do you have any questions, comments, reactions, something? Yeah. Thank you. You're my target audience, by the way. So for that part, you're not my target audience anymore. I'm speaking to the other people now. So how can we ask researchers to do popularization of science? And the usual answers to that, the top answers I get is, okay, it's very nice what you do, but I cannot do it because my topic is too complicated, okay? I hate this argument, and my usual answer is Higgs boson. I mean, the amount of stuff the people did when they discovered Higgs boson is amazing, and Higgs boson is a really tough topic. And they made, for example, this amazing animation movie with the New York Times, like a story in wintertime, which tells with metaphors what a Higgs boson is, etc., etc. So if they succeeded to do it with Higgs boson, you have no excuse for any other topic. There is no topic more complex than Higgs boson, okay? So I never encountered any topic we couldn't try to popularize at a point. Of course, if they say, but people will not understand deeply at the end, yeah, it's not teaching. Okay, it's popularization of science. You have to abandon somehow a piece of rigorous and you're not listening to me anymore, by the way. You're just looking at the movie. Yeah, okay. And anyhow, the reassuring part is when you're looking at the most common questions people ask you at the end of the conference, when you give very nice conferences about deep topics. So the first question I have is a smartphone dangerous? Okay, it's my top question. Whatever the topic of the conference is. I can do quantum physics, magnetism, solid state matter, low temperature physics. I will get this question, okay? And it's a very good question, by the way, okay? Because I'm the scientist, so they can ask. Then I have a lot of questions about liquid nitrogen. Can I bring it at home? Can I do stuff with it? Is it expensive, etc., etc.? And then once again, the questions about what the lab looks like. I never ever have any questions about, in the formula something, do you think this term, etc., etc., about physics itself. Usually most of the questions are about something else. So you don't care that much if they didn't understand everything. It doesn't matter, okay? A lot of other stuff happens in the popularization process. The other argument I always have is that, oh, but I don't work on cosmos and Big Bang, so my thing is not inspiring because my thing is that, and I cannot compete with these people. And here again, I don't agree. You always have a nice way, and we do a lot of trainings showing people that they always have a nice way to present their stuff. For example, the right panel is in fact superconducting levitation, so you can have a nice way to present it. Ah, that's a good argument. I don't have the money. Okay, fair argument. Okay, you have the same argument, I guess. Yeah. So the first answer I give them in France, at least, is that in many research grants there is a dissemination section we talked about. For example, in European calls or stuff like that. And they can put stuff there, and they can devote a few % of their grant to that. So usually when they got the grant, they don't want to spend the money anymore. Okay, they want to keep it for themselves. So what I do usually is when they write the grant, I come to them and say, do you want to collaborate? Take just 3% of your budget, put it to us. We're going to help you write that dissemination part and say what we want to do. And if you get the budget, then you give us 3% of it, and we will do the dissemination. And when they don't have the money already, they think it might be a plus for their call, and usually it's a plus. And then we take the 3%. And 3% doesn't look a lot, but when you have a budget of, I don't know, 500,000 euros, which would be a typical grant in France, that becomes a sizable amount of money for outreach. And the other answer usually is, I don't have the money, or I don't even know where to start, and I don't have time. So usually, let me give you typical possibilities you can give researchers that they would perhaps be okay with. So I distinguish 3 types of researchers, okay? The worst one, okay? He has no experience in outreach. He has no time, he has no money, okay? This one is perhaps better. He has no experience, no time, but he has money. So that would be the typical guy who just got the grant, you know? But he has no time and no experience. And this is the ideal case. I don't even care about that guy. If he's already into science communication, that's fine for him, okay? So let me give you a few examples of what I said to the first one. So I tell him, I understand, you don't have time, you don't have money. I'm going to give you typical actions that will take you just 5 minutes, okay? And just try. So the shortest one is answer science questions. So go to Physics Stack Exchange or Chemistry Stack Exchange or that website, okay, which gathers questions of the public on science. And just click and answer one question. I don't want anything anymore. Just click and answer one question. It's already science popularization, okay? If you're lucky enough, he will like to do it, he will feel proud about it, and perhaps he will answer a second question and a third question, etc., etc. So the idea is always to find a very small first step, and if they like it, then try a further step and a further step and a further step. What I always advocate them to do is, we always have these students who call because they are doing a science project and they need to speak to an expert. So it's not very long, not very engaging, you don't have to prepare anything, you just make them come to the lab for 1 hour. It's easy to do, and it can be fun. Also, if they are not easy with people, but they like to write, I say, well, try to write something, but don't try to write a big scientific popularization article because it's too long, too boring, too hard to do. Try something shorter. So there are many ways, for example, blogs, or many other places in internet where you can write stuff short. For example, The Conversation is a nice website where you write small stuff. It's only scientists and university people who write on this website, but they are helped by journalists from the website to write it nice, and it's very efficient. Contribute to Wikipedia. You don't even have to have an account You just click modify and you modify. Okay? So go to your field and write something. Contribute to social networks. My personal favorite is Twitter, but you can contribute to many other social networks. And just give in a few words your last discovery on Twitter, for example. And there are many ways to do it. We are organizing, for example, specific trainings for colleagues to work on Twitter. So we say to them, okay, in 2 hours, we will teach you how to use Twitter and how to communicate on Twitter. And it's easy to do. And we have many people participating to these trainings. Participate to a public action. Don't try to organize anything yourself. Just come. We'll tell you, okay, there will be this, I don't know, science night that you organized or whatever, science fair. Just come there, be there at 10, leave at 11, and just have fun in between. And when they are there, usually, if there is a nice contact with the public, they will want to stay longer. And then you win. So science fair or whatever format. In France, I don't know if you have it here, Pint of Science. So you're in a bar, and I don't know if you have the equivalent, and you just drink beer together with a scientist who explains stuff to the other ones, but no PowerPoint, just drinking beer together. The second target is researchers with no experience, no time, but they do have money. So basically the main message is take their money. Don't ask them to do anything because they don't have time. They are so famous and a lot of money to handle and a big team. So tell them, we understand your problems of time, so give us a little bit of money and we will do it for you. And then go to the PhD student of the team or the lower in position person of the team, not the big boss who doesn't have time, and ask him to help you a little bit in a specific project that you will handle for him or her with their money. So ask them to collaborate, basically. And there are many ways to collaborate with other colleagues, with science museums, with communication services, and with creative people here again. If you have money, of course, everything is easier. And these people, well, no, these people, it's not interesting. Just ask them to do everything because they're happy to do it. One thing also we try to promote a lot is trying to do trainings and teachings of science communication among our colleagues and among our students. So, for example, my physics students, undergraduate physics students, I give them a course in outreach, okay? And when you do these courses, you never do what I'm doing here, which is awful, okay? What I do usually is I gather all the students in a room. We have 5 days, okay, workshop format. And I tell them, okay, this is the challenge. In 5 days from now, you will have to do a public science show, all of you together during 1 hour in front of 200 people. Okay? And we're going to have to find a way to do that all together. So we'll do small projects in groups. We will help you. We will give you small courses in between during the week to give you different ways to do pedagogy, formats, etc., and to create that big show. And at the end of the week, there will be a big show and you will have to do it yourself. And that works very well. We did it for the past 6 or 7 years, and we had amazing shows. And it's even better sometimes. The show is so nice and the students are so happy that they want to do other shows. So we tell them, okay, so now go to the high school in the city and go to that other high school and go to the university, etc. And then you have a free show of science that you can make travel everywhere with young students, which is very appealing. And that's all over Europe. There are many science shows all over Europe. This is an association of all the science shows in Europe. But I checked and there is none in Lithuania, at least in Latvia, sorry. But there are many, for example, this one is from Poland, okay? And they gathered in an association, so you can just pick examples and look at what they are doing. And it's not very hard because physics students or science students are very happy to share. They have no opportunity to share at all with the others, so it's a new opportunity for them. So we always find motivated candidates for that. And if you're interested in that, we documented that, so we made articles and specific recipes to tell everything we do in these 5 days to make it nice and entertaining, and it's in English. Questions, comments, anything you'd like to share? Did anyone try to train his students in universities to science communication here? No one? You have to. You have to, because the idea is that then, for example, we did that for the past 6 years, so now the first generation is in PhDs, and during their PhDs now they are doing outreach because it's so natural for them. And they will become researchers, and so in a few years from now we hope to disseminate because we took them from scratch. And you can do that with your colleagues. It's harder, but you can try. One other thing is to promote collaborations between researchers and science centers. So we did a lot of that. For example, we train science explainers with physics. We bring them to the lab, we explain them physics, and we build with them new animations or new exhibits. And of course, it's nice because then you can really bring your own research into the Science Museum or the Science Association. So this is my summary. The summary is, okay, popularization of science is a key issue, but since you are here, I think we all agree on that. Well, I hope. But one very important point which not all people agree on is that we need researchers in the game. They should not do all the popularization for sure, but they need to be there at a point because they have a key role here to defend who they are and their field. There are a lot of formats and possibilities. It's not necessarily just a standard conference. It can be many other stuff. It can be a short videos, it can be cartoons, it can be very different ways, and you can explore new ways. And you also have many levels of involvement, so you don't need to spend that much time to start. And I would always ask new colleagues to start at a very small level, and if they had fun, then to go at a higher level and a higher level and a higher level. And doing that very progressive training, we got colleagues who are not into popularization at all, really involved at the end of that journey because they did it step by step. And this is it for me. Thank you.
Okay, I'm on. Oh, wow. Thank you. It was fun. I just wanted to say a few things because I didn't want to interrupt or everything. About YouTube channels, I don't know how familiar all of you are with YouTube. It is like that, like the young people, for me exactly, like I don't use TV for like 7 years now, and I live in YouTube because I can see what I want. And just this morning I saw one man saying that in Latvia, 170 people have subscribers more than 1,000 in YouTube that makes content, usually about whatever they want, magic, their daily life or something. And I think in Latvia we don't have any science YouTube channels. And I love them because I knew the American ones, I didn't know the French ones.
Of course.
Of course. Right, yeah, because science is fun, and when you like show it, for me who doesn't know any science, it's
I was amazed to learn that there was no YouTube science channel in Latvia. In France, of course, so YouTube is the second most visited website. First one is Google, okay? YouTube is second. And exactly as you said, I have two daughters, exactly the same story. I never had the TV at home, and I was so proud of it, and they spend all their week and all their day in YouTube. So it's the new channel. And when I ask my students in physics, what is their first source of information on science, it's YouTube. All of them, it's YouTube.
Yeah.
So you have to be there.
And for me, like YouTube, like really got me into more of science. It seemed more fun, and everything like that. Also, I wanted to say, that's for you. You mentioned just lastly that we don't have any science shows. We don't? I guess we don't. And my friends, we have like this little. We do. Yeah, that's what I wanted to talk about. We have Zinzino, yeah. Par to jūs gribētu teikt? Zili brīnumi. Zinzino.
I was thinking about science shows by students. Do you have that?
I guess not. And okay, everyone. Does someone have any questions?
So, what's your job? How do you manage all of your researcher? I've tried to make some. I've made some presentations, let's say, for non-chemists or non-researchers. It takes a lot of time actually to put together one decent presentation for 10 minutes.
Yeah, you're completely right. So it's time consuming, and that's the usual argument. So my case is special because I had two lives. Okay, the first one, I spent 20 years doing fundamental quantum physics research. When I did that, I limited my outreach only to conferences in high schools. So I just limited the time. It took me time to prepare the stuff, but when it was prepared, I just did it the same for hundreds of times. So it didn't consume that much time. And the other argument is that I bargained with my university to count these as a teaching. I have to do 200 hours of teaching as a physics professor, and I bargained that each time I would go in a high school to do these talks, it would be counted as 1 hour for my duty. So I think that's very important. Otherwise, I couldn't have done it. In the second part of my life, I said I'm going to quit quantum physics and create a new group on these activities, and the research will be with human science. So it's another story.
Okay, I would like to ask a question about that, about what to speak. We all know very well that there is 95% dark matter or on dark energy. We understand only 5%. Now, how you are dealing with public, if people are asking, please explain me what is dark energy, what is dark matter, and you don't know. How to explain these things which we don't know.
This is a very good point. So first, you're completely right, and each time I'm doing a talk on any topic but astrophysics or cosmology or dark matter, I get these questions. I always get the question about the Big Bang. I have no clue about the Big Bang. It's not my specialty. So the first answer is, I don't know. And I think it's very important because for them, the scientist is supposed to know everything. But then I keep on doing, okay, what as a scientist can I do to answer the question if I don't know? And I think now I switch to the method, you know. Same story when I have these weird questions. For example, in France, people are fond of homeopathy. You know that? It's the same name, okay, medicine. Yeah. And they use a lot of quantum physics as an argument for homeopathy. Okay, because there were weird people who told that quantum physics could explain homeopathy. It cannot, believe me. And so people attack me telling me, but as a quantum physicist, you should say that homeopathy is okay and that it proved, etc., etc. I never answer stuff like, I don't believe in homeopathy or something like that. I always start that, it's a good question. I have no clue. Now let me tell how I would do as a scientist to try to understand if quantum physics can play a role or not. This is how I would do the experiment. This is how I would try to duplicate and to replicate, etc. And then I go to the method and the scientific process. And at the end of that long talk, I say, and these type of experiments have been done, and it didn't give any conclusion. So we can say that from the quantum, etc., there is no proof of homeopathy. But I never go directly to the debate. So now, when you're asking me about dark matter or dark energy, I think it's a very good question. And my immediate answer is that in science, we don't know everything. And then the nice part about it, otherwise I would not have a job anymore. As a researcher, we keep on working, and we don't even need dark matter. Did you see that small levitating fun bird? We have no clue how it works. I have spent 20 years of my life trying to understand the origin of superconductivity in the black pellet. And I did not. And we are thousands of people around the world trying to understand why there is superconductivity in this black stuff, and we have no clue. So you also have very big mysteries in small stuff. And I think that's one of the main messages. Science is not there to understand everything. Science is there to see what they can understand, put a method to it, and trying to get answers.
Small comment. Maybe it is worth more to speak about that with small children and to show that there is a lot of work to do in science in future. That nothing, we know only 5% and 95% is unknown.
That's a good point. A lot of people in science communication, I don't know if you have the same here, tell me that the most important target is young children. I don't agree with them. I have to say, I don't like small children, okay? It's personal, okay. But I have teenagers and it's even worse. But of course, a lot should be done to small children. The usual argument is that small children, I mean, they will become big and you have to educate them from the beginning. My personal experience as a father is that then you have the teenager time, which wipes out everything, you know? You became a teenager and wow, things change a lot. So I think it's also very important to talk to them just after the teenager time. So my main target for all this high school and stuff like that is from 16 years old to 20 years old. And it's the moment where they decide for their career, where they decide for their life, and where some of them will not hear about physics anymore, and it's perhaps the last time they will hear about physics. So I think it's a key moment. I don't mean it should be the only one, but in France, many people focus only on children, and I try to advocate that young adults are very important as well. But it's a personal taste.
Any more questions?
May I comment something? Because in 2018, the master's degree got 5 physicists in Latvia. So I think we are talking about a different amount of audience and different people, because of course we know the issue. We must talk with small children already to wait some better times in physics after a while. But still, I think also the funding for this popularization thing and that are quite different. And I think we are just like starting with this laboratorium, scientists night, and so on. Maybe we are doing a lot of things wrongly, and thank you for like showing how it goes in France. But, so we can start with small actions and small steps forward. So hope after like a while there will be at least a big deal.
Yeah. I would say that, so first I don't want to tell you what is wrong or right. I just give you examples of the kind of stuff we do. Some of them are really without any cost. So that's my message. If you don't have money, there are many stuff to do without any money. Some of them are, of course, expensive. Most of them are really cheap or just your time. But so that's one message. And the other message is, if you have a real issue of having students going to physics degrees, master degrees, etc., then your main target should be undergraduate students, first-year university students. That's one of my targets with the science breaks, for example, and stuff like that, showing how nice physics and science is. So not targeting at kids, because you don't have time for that, and you cannot wait 20 years. So just target the first-year university students and showing them how physics is amazing, making visits of labs and stuff like that. I would
But still we have also in the first course it's like 20 people. So.
Okay, so go to high schools. So high schools.
Yeah.
I started with high schools myself, and I think high schools are a good target audience, but yeah.
Well, it could be future prospects, let's say, for maybe chemists you see are there's firemen, there's this and that, for biologists as well, but for physicists, well, it's probably people view it as more fundamental. So maybe just show those prospects where they can achieve it at some board places.
Yeah, just take out your smartphone from your pocket and we'll talk about physics. I mean, it's just pure physics. We are doing a lot of trainings, for example, with smartphones. We're taking the smartphone in high school and showing them how this contains a full lab of physics and how it's just physics, basically.
Yeah, I understand that.
Yeah.
Just.
But we do practical, for example, we did a treasure hunt with smartphones, where with your smartphone you can detect a lot of stuff and use it as a physics lab and end up with a nice game, entertaining game using your smartphone, just to realize how much physics you have in your pocket and how physics can be practical as well. But I agree with you that it can be an issue.
Anyone else?
I just want to comment that I have done the 3 minutes, and it was really complicated. There's like 3 minutes in science, and it was in Tallinn, but still, like the bell rings, and they're like, just shut up. And like I got it until the end, but still, it was really challenging and really interesting. I was inspired by that.
Ah,
to do that.
thank you for that comment. I had many students who did it, and basically the competition they didn't care.
Yeah.
But the training they got to do it was the interesting part. And many of them ended up doing real talks and science talk because they were so frustrated by the 3-minute story that they did 30 minutes, etc. But it was here again the first step. They had to do it because the university asked them to do it. They got trained with it, and then they decided they wanted to push it forward.
Yep.
Have you tried thinking about what, sorry, I'll start from the other end. We see that all of this has to be interesting, whatever it means. And I have been struggling about the actual meaning of the word interesting. And I'm wondering if you have tried to define the criteria, what the science, what qualities should it possess, this kind of communication with whatever audience?
Okay, there's a huge literature about that from the world of science of communication and information, and it means many different stuff for many different audiences and contexts. So I think depending on the context, who you are talking to, in which kind of channel and medium, the answer would be very different. So I don't have a general broad answer to that. And just to make it more provocative, I don't think it should necessarily be interesting. Sometimes being boring is also nice. But I advocate for that, but I tell it to people. Sometimes in my conferences, I tell to people, okay, now we're going to have 10 boring minutes, because science is also very boring sometimes. Okay, because sometimes you have to struggle against something very difficult, or you have to do it again and again for 20 years. So let's do this 10 minutes, and I'm going to ask you to be with me and to get bored for 10 minutes. And I think it's a nice message because young generations don't know what boring means. Because you always have your smartphone, basically, okay? And we don't know anymore what it means. But I mean, I got bored when I was young, really, but you don't know what to do. So I tell them, okay, put your smartphone down, and let's get bored all together for 10 minutes. And it's amazing the attention you get when you tell that. They are so surprised. And you tell them, doesn't matter if you get bored, let's do 10 minutes like that together. And when I teach, I do that, but for hours. I tell them, this course will be boring, I have to warn you. And you're going to enjoy that, and let's try it. So because we should not lie to people. At the end of the day, science is not just fun. Science can be very boring, science can be very hard, and you need to be very patient, and to be stubborn, and to be etc., etc. So I think we also have to tell that. For example, I always try to discuss the time scale. This small discovery I'm telling you about took 3 years of 2 people's life, full time, with experiments which lasted 6 months, day and night, and which were just boring points on a computer screen. But still, it was fun to do it. But I think we should not just have a message of, oh, it's fun, entertaining, and wow, it levitates. I think you have to have the 2 messages at a time. But saying that, I did not answer at all your question.
Anybody else? No? Last time, last chance. Okay, I guess not. Okay, big thank you to Professor Julien Bobroff. I guess there will be opportunity to still drink coffee and maybe have a little closer chat with Julien. So thank you everyone for coming. And Julien, it was great. It was entertaining. It was awesome. Thank you.
And thank you to you.